Alright. Hi, my name is Kit, and I am going to show you the proof for the sum and difference equations for sine and cosine, if time allows me. Come over. So, you probably don't exactly know what the sum and difference formulas for sine cosine actually mean. Well, they're related to the unit circle, which, if you've taken trigonometry, it's the first thing they teach you. Anyway, when you have a point on the unit circle, say, like point C way out here, it's pretty easy to measure from the x-coordinate to that point. But, what if you move that point, and then draw another point? Now, all of a sudden, you don't have that. You have this angle out here, and then your alpha angle's gotten bigger. It's a whole mess. You can't. This is outside the triangle, and so is this. And you're trying to focus on what's inside the triangle. It's not a full 180 degrees because it's not a straight line, and it's not the angle that you had before, which was alpha. Alpha's now grown. So, what you have to do is subtract beta from alpha. And that's where these formulas come in. But how do we know they work? Well, this is how. First, you turn these points into actual coordinates, because cosine of anything is x, and sine of anything is y. These will always be constants. So, you've got P out here, and P has the angle alpha. So its coordinates are cosine alpha and sine alpha. And then you've got Q out here, because its angle is beta. Its coordinates are cosine beta and sine beta. Now you've got C. C's the tricky one because it's the one that's messing things up. Its coordinates are cosine of alpha minus beta and sine of alpha minus beta. And then its partner is point D, which is the x-axis, 1 and 0. Now, these two triangles are exactly the same. Since they're both on the unit circle, they have the same lengths, they have the same dimensions. It's just a matter of figuring out, okay, how do we actually measure those dimensions? So, these two are equal, and these two are equal. That is going to become important later on. So, how do we figure out what to do with these points and how to get our angles? Well, start with P and Q and the distance formula. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. That's how it's written with those. Now, look at these. These are, I do not remember the mathematical term for it. I'm just going to say these are squares of combinations of terms. So, what do? You FOIL. Great little thing. Foiling two sets of sine and cosine things is a little messy, but it still fits under the square root. So, it becomes this. You then combine them, they become this, and then, look at that. You have terms you can work with, because what's the Pythagorean theorem? Sine squared plus cosine squared equals 1. Because addition is, swappable, you can change that order. As long as you're not changing it across the equal sign. So, you now have cosine squared, and you now have sine squared. Two pairs of them. You now have two 1s. And so, when you combine them, you end up with D equals 2, the square root of 2 minus 2 cosine, and then the middle terms that you'd gotten from foiling the equations. But, you may ask, what do you do with that? Well, nothing yet. But, because D is a lone term, you can't really mess with it without, screwing things up algebraically. However, PQ, which is what this is, equals CD. So let's get CD. The distance formula for CD is cosine of A minus B minus 1 squared plus sine of A minus B minus 0 squared. Well, FOIL those out, and then simplify them down to d equals the square root of 2 minus 2 cosine of a minus b. Now, d as a variable now equals two things. What does that mean in math? It means those two things equal each other. So write it out. Square root of... Well, look at that. You now have square roots on two sides of the equal sign. What can you do with that? Well, you can square them both and get rid of it. Doesn't that look so much nicer? Well, you also have, because you have to get cosine and sine alone, you also have 2's on both sides. And look at that, you can just subtract them and they become zeros. But what else? You also have negative 2 times in your cosines and sines. So what can you do? You can divide both sides by negative 2 and it gets rid of it. And you end up with the actual formula for the difference between the difference of cosines, which is... okay. The rest of the formulas for sum and differences are derivatives of that, where you, like, for example, the addition one. Anything plus anything is anything minus the negative of that. So you turn positive b into negative b and just continue the formula, and it simplifies down to that. But that's all we have time for right now. See you next time.